Hey, welcome back. And this lesson, what we're looking at is air pollution. So we looked at water pollution last time and the effects, especially things like eutrophication. Now what we're looking at is air pollution. So first of all, I'd like to go through these 5 questions. So pause the video and attempt these questions, please. So here you go. Here's the answers then. How can rivers be polluted? Again, we looked at that before. Fertilizers, remember leaching, pesticides, insecticides, sewage, sulfur dioxide and plastic waste. Where can harmful waste be released from? Factories, power stations, homes, sewage works that's been flooded. There's loads of different places. Agriculture, you've got to think about maybe cattle farms and all that feces that's being swept into the sewers sometimes. What is one consequences of increasing human population, more pollution, greater use of resources? Our resources are finite. We're running out of these resources here. What is algae bloom? Again, this is from eutrophication, so this is a rapid increase or accumulation in the population of algae in freshwater or marine water systems. So this takes the sunlight out of the river, the plants inside can't photosynthesize and therefore they die. Microbes grow and start using all the oxygen. So the oxygen is used up within the river or the lake. What is the name given to living organisms that can show us the level of pollution in a river? Bioindicators. We'll look again at that today, but a different type of bioindicator. Now, with this, there's quite a few key words with this bit that I just again want you to put into your glossary. These are important. These are going to come up as we go through this PowerPoint. Acid rain, hemoglobin, that's the red protein found in red blood cells, is what makes it red. Greenhouse gases, again, we'd have covered some of this before. Greenhouse gases, remember carbon dioxide, methane, water are the main greenhouse gases. I have put nitrous oxide, but the first 3 are the main ones: recycling, reusing materials, particulate matter. We talk about that a lot, the PM size. Okay, we talk about this when we talk about gases, and it's 10 micrometers or less. Combustion, hopefully you know the equation for that. So this is a process of burning by heat. So we have a fuel plus oxygen gives us carbon dioxide and water. Global warming, we've talked about that. We've got complete and incomplete combustion. They're completely different. If you think about a Bunsen burner, when we've got the blue flame, we have complete combustion. Okay, we got water and carbon dioxide released from that. Okay. With incomplete combustion, don't have as much oxygen there. It's limited, and that's when we get carbon monoxide being produced. So we've got pollutant, smog, soot and fuel. Again, like I said, add these please to your glossary in the back of your books. So air pollution. So a lot of air pollution we think about combustion of fossil fuels, and these release carbon dioxide, has an effect on the greenhouse effect, leads to global warming. So when we burn fuels, especially coal and fossil fuels, it also releases sulfur dioxide and nitrogen oxides, which can cause acid rain. So air pollution can also be caused by teeny or tiny particulates. Remember that PM number for smoke, which can cause smog as well as other things. So here we can see this is a power station. It's releasing lots of gas into the air. Now a lot of those, if you look at the large chimneys there, the fat ones, they're releasing water vapour. But again, remember that is a greenhouse gas. And they've got other chemicals coming from the stacks, the tall, skinny ones. Okay. Things like carbon dioxide, sulfur dioxide. Here you can see some other effects. So the top one, smog. Now a lot of cities have smog, especially ones that are quite densely packed. We see this a lot in China as well. Not the only country. And since the lockdown, we've seen this reduced. Now a lot of that is produced because of cars. They are burning a fuel. Okay? Not always complete combustion, and also they release particulates into the air. It's one of the reasons they're thinking about banning or having taxes on diesel cars within major cities. And the bottom one, that's the effect of acid rain. Okay, so that's the effect of acid rain on trees. And again, we're going to talk more about that as we go through this PowerPoint. So, again, you're going to need to pause the video. I've got 3 questions there that I would like you to have a go at, please. So here, give examples of how gases and pollutants are released into the air. So burning fossil fuels in power stations, combustion of wood. That particularly links back to the carbon cycle, and when we're talking about deforestation. Combustion of fuel in vehicles, so that could be petrol, diesel. Farming of cattle and livestock. Remember, they excrete methane gases. Growing rice in paddy fields, again, methane is being released, and incomplete burning of fuels. So what is the name of the atmospheric process which keeps the earth warm by absorbing radiation from the sun? So we've got the greenhouse effect there. Okay, we talked about that before, and how that these gases are causing our planet to warm up, and it's causing climate change. What gases are produced from burning fossil fuels? So again, we've got carbon dioxide, sulfur dioxide, nitrous oxide, and water. Again, water vapour is one of those greenhouse gases that we don't always think about. But from any combustion, we're going to get water. So acid rain. So fossil fuels naturally contain sulfur. So these produce sulfur dioxide when they're burnt, a gas with a sharp choking smell when the fuel is burnt. So when sulfur dioxide dissolves in water droplets in clouds, because obviously it goes from the power station or wherever it's being burned, it rises upwards, it dissolves and reacts with the water, and it makes that rain more acidic. So this is called acid rain. So if you've got something like sulfur dioxide, we're forming sulfuric acid. If we've got nitrous oxide, we're forming nitric acid. So it forms an acid. So here we can see an example of what's happening. So nitrous oxide, sulfur dioxide, forming these acidic gases. They can be blown long distances. Okay, so that it's not just localized. Some of these can be spread quite far into other countries. And then these gases then fall on the land, and we're going to talk more about that in a minute. But plants, animals, lakes and rivers are damaged by this acid rain. So chemical reactions involve air pollution to create an acidic compound. I just said that it can cause harm to vegetation and buildings. Sometimes when an air pollutant such as sulfuric acid combines with water droplets, that makes up clouds. These water droplets become acidic, and then when the acid rain falls on the area, it can kill trees. Okay, it reacts with chemicals within the soil to create poison. Also, it makes the soil more acidic. It can harm animals, fish, because the lakes become acidic. It means that the fish then can't use their gills efficiently to remove the oxygen from the water. It can affect other wildlife as well. Okay, not only does acid rain kill wildlife, plants and animals. It can also cause weathering. So here we can see two pictures, the same statue. So over a 60-year period, due to acid rain, we see the weathering of this statue. Okay, so the acid rain has reacted and has caused this weathering. So this can happen to statues that we see, also happens to buildings and rocks this can occur to as well. So as we said earlier, this acid rain can damage plants. Okay, so when the acid rain goes into soil, it changes the chemistry, it becomes more acidic. The trees can die from that because a lot of plants need a particular pH to their soil, but also kills the wildlife that's in there as well. They can't survive. It's destroying the habitat, so they've got no nutrition, or their homes are destroyed because the trees and the plants are dead. Also with plants, acid rain destroys the waxy layer on the leaves, and this again makes it difficult for the trees to absorb the minerals they need for healthy growth. And again, this can cause death to the trees. So the waxy layer is the top layer on the leaf. Here we can see the effects of acid rain on a forest. So you can see it's done quite a lot of damage. So, and as we mentioned previously, acid rain also changes the chemistry of the lakes and streams. So it harms the fish and other aquatic life. They can't withstand the acidic conditions and the low pH that is now there. Again, this is quite an extreme case, but you can see this is what can happen. It's killing all the fish there. This lake has become acidic and the fish have died and they float to the surface. Again, this has its own issues on water pollution as well, but this has been seen all around the world where lakes, streams have become too acidic for the aquatic life to survive. So what I now do is pause the video. Another 3 questions that I'd like you to have a look at, please. So, which gas produced by the combustion of fossil fuels causes acid rain? Sulfur dioxide is the main one that we think about. What are the biological consequences of acid rain? Damaged trees and forests, dead fish in rivers and streams. So there's quite a few consequences there. A flow chart to show how acid rain is produced. So cars and power stations burn fossil fuels. Acidic gases such as sulfur dioxide and nitrous oxide are produced. Gases are carried in the winds in the atmosphere, and then the acidic gases in the rainwater react to form an acid, and then the acid rain falls. So when we looked at water pollution in the last lesson, we talked about bioindicators. They were all invertebrates. Now also plants or lichens can be used as biological indicators of sulfur dioxide pollution. So these grow in exposed places such as rock or tree bark, which means they easily absorb water and nutrients to grow there. So rainwater contains just enough nutrients to keep them alive. Air pollutants dissolved in rainwater, especially sulfur dioxide, can damage lichens and prevent them from growing. So it's an excellent indicator. So bushy lichens need really clean air. Leafy lichens can survive a small amount of air pollution. Crusty lichens can survive in more polluted areas. In places where no lichen is growing, it's often a sign that it's heavily polluted with sulfur dioxide. So it's a very good indication for those, just like the invertebrates were. So here we can see some lichen on the trees, showing it's a nice healthy environment. So again, just a quick question based on what we just looked at. How do lichens indicate levels of air pollution? So lichens cannot grow at all in very polluted air, so an area where none are growing will be polluted. You can see these lichens often if you go into the woods, have a look on trees, you can see this growing. Now, we talked about the PM number and the particulate matter earlier on. So air pollutants can be in the form of particulate matter, particles, very small particles, which can be harmful to our health. So the level of effect usually depends on the length of time of exposure. So the more you're exposed to these pollutants, the more damage it's going to do to you. And it will build up in your lungs. So it can cause that upper respiratory infections and throat infections. Sometimes it can cause irritation to the eyes and nose. So that's short term. You can get headaches, nausea, allergic reactions. It can aggravate medical conditions, especially if you've got issues with the lungs like asthma, emphysema, and long-term effects can include chronic respiratory disease, lung disease, heart disease, and it can also damage the brain, nerves, liver or kidney. So it can do quite a lot of damage, and this is a reason why I said earlier about them wanting to reduce the amount of diesel vehicles within cities, because if there's a lot of diesel vehicles there, this particulate matter builds up. Many years ago I used to work in central London, and the amount of vehicles and cars there, and it sounds disgusting, but when I got home in the evening, I'd have to have a shower and it would just run off me black because of all the particulate matter that would build up on my skin, but also my snot, sounds disgusting, would be black and crusty, which is not really the nicest thing there, and often I'd get sore throats, and when I coughed, again you'd get the black sputum come up. So, in UK cities, what type of cars are they trying to reduce and why? What effect does smoke and particulate matter have on buildings? So think about that. Think about what's happening to some of these buildings in built up areas. What can help to reduce the amount of waste and pollution in the environment? So again, pause the video, see if you can answer those 3 questions. So here we are. So diesel vehicles as they produce large amounts of particulate matter. So even though diesel vehicles are more efficient, so when I had a diesel car I could get more miles per gallon, actually it's a particulate matter that's doing the damage. What effect does smoke and particulate matter have on buildings? Cause the blackening of buildings and make the cities look dirty. So again, when you're living in London, sometimes what I used to see is them spraying down or washing the buildings. You see this black muck come off, and it really does build up quite quickly. What can help to reduce the amount of waste and pollution in the environment? Reduce, reuse, recycle. We've mentioned that before. Use cars less, walk, cycle, use public transport, use renewable energy where possible. It's one of the reasons they want to use electric and hybrid cars now, because there's less pollutants come out from the exhaust. But obviously the more you can walk or cycle or use public transport, the better it is for the environment. I know it's not always available, but the more we can do that, the more pollution, or the less pollution that we're going to release. Through this lockdown, we've seen cities now, their smog is being cleared. We've seen water, especially down in South Sea, the seawater become clearer. So it is definitely having an effect with less cars being on the road. And actually people are feeling healthier and being able to walk more. And then question 11, the release of sulfur dioxide affects our environment. The graph, which I'm going to show on the next slide, shows how the mass of sulfur dioxide released in the UK has changed from 2001 to 2011, so a 10-year period. So here we go, and mass sulfur dioxide release in thousands of tonnes and the years. So I want you to go and describe the pattern shown in the graph. Okay, so you'll have to look back in the last slide, and in 2001, 1,400,000 tonnes of sulfur dioxide was released, by which year had the amount of sulfur dioxide released reduced to half of that amount. So here we go. The mass of sulfur dioxide decreases and then levels off. It plateaus. Nice, good word there. So half was 2008. It's really important that you can interpret graphs and have a look at those. Explain why some countries that have strict controls on sulfur dioxide emissions still suffer from acid rain to their buildings and ecosystems. So there are some that do have tight control. So here, sulfur dioxide and nitrogen oxides can be carried high in the air by winds. So you may not produce any pollutants, but those acidic gases can be blown from other countries, and then that can fall as acid rain on your country. So the more control we can have across Europe and across the world, the better for all countries involved. Now, it's coming to the end of my time here. So I have 3 summary tasks I'd like you to choose from. So we've got one here, produce a cartoon strip to show the production of acid rain and its effect on the environment. Love some pictures. Just go with that. So you could do that one. Complete the table below, giving at least 3 causes for the pollution type with examples: so air pollution, water pollution, land pollution. So things that you've looked at during previous topics. And then the final question or final task is here. Research the actions that have been taken at local and global levels to maintain air quality despite the need for industrialisation and fossil fuel use. So we all need to use fossil fuel, and industry is a part of the human population. Is what we need. So this is what I'd like you to have a look at. There's some web links there for you to have a look at and have a go. Thank you very much, and I will speak to you all soon.